Let's talk about one of those invisible pieces of tech that makes our digital lives actually work. It's a hidden helper tucked away inside your router that you've probably never even heard of, but you absolutely rely on it every single day.
You've been there, right? You've got a great connection, full bars, everything should be perfect, but for some reason, that video call just dies or a file transfer gets stuck. Well, turns out the problem often isn't your internet speed. It's actually a really fascinating networking puzzle that's happening right inside your router.
So, here's the game plan for this explainer. First, we're going to unpack what I call the NAT puzzle and figure out why some protocols just seem to break. Then, we'll introduce the hero of our story, the gateway solution. We'll break down exactly how it works, step by step, and then we'll look at all the common apps you use that absolutely depend on this thing.
Okay, so before we can understand the fix, we really have to get our heads around the problem. And that problem begins with a core piece of how the internet works called NAT, which stands for Network Address Translation.
The easiest way to think about NAT is to imagine your home network as like a big office building. All your devices, your laptop, your phone, they each have a private internal office number. But to the outside world, the entire building shares just one single public mailing address. NAT is basically the receptionist at the front desk. It takes all the outgoing mail, slaps the building's main public address on the envelope, and sends it on its way. It's a super clever way to handle the fact that we don't have enough public IP addresses for every device on the planet.
Now here's the catch, and this is the crucial point. That NAT receptionist, they're only looking at the envelope, what we call the IP header. They change the address on the outside, but they have no idea and no permission to look at what's written inside the letter. And that is where things start to get complicated.
So how does this actually break things? I mean, for just browsing the web, NAT is perfect. It's flawless. But for more complex apps, the real issue isn't on the envelope at all. It's hidden deep inside the letter.
Take a look at this, because this shows you the key difference. On the left, you've got a standard data packet. All the important address info is right there in the header. On the envelope, simple. But look to the right. A lot of modern applications, like video calls, do something tricky. They also write your private IP address, your internal office number, directly into the data payload. That's right, it's inside the letter itself.
And boom, there's the breakdown. Our NAT receptionist does his job perfectly. It changes the public address on the envelope, but remember, it can't open the letter. So that private internal address inside the data payload, it goes out into the world completely untouched. The computer on the other end gets the message, and it tries to reply to that private address, which is like trying to mail a letter to Office 101 without knowing the building's street address. It's impossible, it's unreachable, and the connection just fails.
So how in the world do we fix this? How do we make that receptionist smart enough to actually read the letter? Well, we give it a very special assistant. And that assistant is a piece of software called an Application Layer Gateway, or ALG.
You know, that's a mouthful. But what an ALG really is, it's a specialist. It's a purpose-built feature inside your router designed for one very detailed job: to be the middleman for these complicated applications. It understands the unique language these protocols speak, and it knows exactly where to look inside the data for those hidden IP addresses.
Let's go back to our analogy. If NAT is the receptionist, the ALG is their highly trained, security-cleared assistant. When a packet from one of these tricky apps comes along, the receptionist just hands it over to the ALG. The ALG has permission to open the letter, find that internal address, correct it to the proper public one, and then seal it back up. Just like that, problem solved.
And the impact here is just night and day. On the left, you can see the broken flow we talked about. NAT does its part, but that uncorrected payload means the communication hits a dead end. But on the right, with the ALG in place, both the header and the payload get translated correctly, and the result? A stable, successful connection. It just works, plain and simple.
All right, so we know what an ALG does, which is pretty cool. But let's get into the details. How does it actually perform this little bit of digital magic? Well, it's a very precise three-step process.
First up, it does something called deep packet inspection. That's just the fancy technical way of saying it opens the letter to read the contents. Second, it performs the payload modification. It finds those private IP addresses and port numbers and rewrites them. And third, and this part is so important, it maintains session awareness. A lot of these apps open up extra temporary channels on the fly, and the ALG's job is to keep track of every single one to make sure nothing gets dropped.
Now, this isn't just some obscure theoretical concept. ALGs are hard at work behind the scenes every single day, making sure some of the apps you use all the time can actually function.
So where do you actually find ALGs in action? The absolute biggest one is SIP. That's the protocol that powers most voice-over IP and video conferencing apps. Think Zoom, Microsoft Teams, things like that. The classic file transfer protocol, FTP, is another huge one that needs it. Even certain types of VPNs and media streaming services depend on an ALG to find their way through NAT correctly.
Let's use FTP as a perfect example of why this is so critical. See, FTP is old and it's a little weird. It sets up one connection to send commands, that's the control channel. But then it tries to open up a completely separate second connection to actually move the files, the data channel. And the command to open that second channel contains your device's private IP address. Without an ALG there to see that command and rewrite it, that file transfer would fail every single time.
So what's the big takeaway here? The bottom line? The application layer gateway is really the unsung hero of network compatibility. It's this incredibly smart, detailed solution to a really thorny problem. And maybe its greatest trick is that it works so perfectly that you never, ever have to know it's there. It just ensures our apps work, no complicated setup required from us.
And that kind of leaves us with a final thought, doesn't it? The ALG was this really ingenious fix for a problem created by another technology, NAT. But as our apps and our networks get even more complicated, you have to wonder, what's the next great challenge going to be? And what will be the next brilliant, invisible fix that keeps our digital world spinning?